Welcome to the next lesson in this course, and in this one we are discussing logging as a cross-cutting concern. We will be implementing structured logging using the Serolog library, and we're going to use Seek as our log ingestion and monitoring server. The first thing we need to do is to introduce some NuGet packages in our API project. Let's look for Serolog, and I'm going to install the Serolog ASP.NET Core package because it comes with some logging middleware that we can add to the request pipeline, and it's going to add some informational logs about our API requests. And then I'm going to look for another library called Serolog Syncs Seek, which is going to help us to stream our application logs into Seek. Serolog has this amazing concept of syncs where you can just plug in a NuGet package, configure the so-called sync, and Serolog will automatically stream your application logs into that sync. And there are many popular syncs to choose from. Here are just a few of them. So you have a file, a console sync. There's also a sync for Elasticsearch, Application Insights, then some of the popular databases like SQL Server. You can also send your application logs to Datadog and so on, but we are going to focus on just Seek that we will run inside of a Docker container. So what do we need to configure Serolog? Well, my preferred approach when it comes to configuring structured logging with Serolog is to move my configuration into my application settings. And I need to start by enabling Serolog. So I'm going to say builder host and then use Serolog, which is a new extension method that we can now access because we added the respective NuGet packages. And then I need to provide a delegate that's going to take in a host builder context and my logger configuration. And then I can say logger configuration read from, and I will say that you should read from my configuration, and I can take the host builder context and pass in the configuration value. I'm going to just simplify the name of this argument to make this fit on the screen. The next thing I want to introduce is to add some logging middleware to my request pipeline by calling use Serolog request logging. And this is going to add a middleware that is going to track our incoming API requests and produce some valuable structured logs that I'm going to show you later in a demo. The next obvious thing that we need is the actual configuration values. Now I'm going to paste these values in because there's quite a bit of it to type out, and you can of course grab this from the code snippet that will be under this video. Let's examine what we have inside. First of all, the section name has to be Serolog. This is by convention. Then we can say which syncs we are configuring. This is an array of syncs. And by default, I'm going to say that you should just write out to the console. Then you can configure your minimum log level. The default is going to be information, and you can also override this value for a particular namespace. Then you can configure your syncs in the write to section. There's also another section to support log enrichment, and we're going to enrich our logs from the log context and with the machine name and the current thread ID. Also, you can set some static properties that are going to be applied to most of your structured logs. And for example, I can set the application name to the name of the current application, which is Evently API. I'm also going to add the respective configuration for Serolog in our app settings development JSON. And here I'm also going to configure my Seek sync. And in the write to section, I'm going to point to the Seek server that's going to be running locally inside of the Docker container on this address. And this is the next thing that we need to configure. So let's head over to the Docker Compose YAML file. And I'm going to add another code snippet, which of course you can grab from under this video. What I'm doing here is adding another container that will be called Evently Seek. And notice that the name of this container is what is configured in my application settings development JSON when I'm pointing to this instance. The port is the default internal port 5341. I'm also exposing it outside of this container. And on the port 8081, I'm exposing the Seek dashboard that I'm going to show you in a demo. The image that I'm using is Datalust Seek latest, and I'm also configuring the container name. And now I'm going to add our first mediator pipeline behavior in the common project. Let's head over to application and let's create a new folder here called behaviors. I'm going to add a class inside that's going to be called request logging pipeline behavior, and you can grab this file from under this video. We're going to need a reference to Serolog in this project, So let's go ahead and install the base Serolog library. I'm going to install the latest version. And if I go back to my pipeline behavior, you will see that we're no longer getting an exception that we are missing a reference to Serolog, but we still don't have access to iLogger, which is available in Microsoft Extensions logging abstractions. So that's also what I'm going to install. And now let's examine what we actually have inside of this pipeline behavior. First of all, this is an iPipeline behavior, which is an interface coming from Mediator. And this allows us to implement a sort of a middleware pattern around all of our commands and queries. This is also a generic interface, so we can target all of our commands and queries, or we can decide to scope it to a particular set of commands and queries using our generic constraints. The only dependency I need here is an iLogger, which is also going to write out our logs using Serolog behind the scenes. In the handle method is where we are doing the actual logging, and what I'm doing here is grabbing a module name based on the current type's full name. I'm kind of abusing the fact that I'm using a particular naming convention where I can just find the module name based on splitting the request name and then taking the value with the index of 2. And what I mean by this, if we open up the events module, you will see that the name of my module is the third component in all of the project names. This is a slight hack, but it simply works, so I didn't want to complicate things anymore, and this is what I'm using for fetching the module name. Then I'm also grabbing the request name from the current request type, and I'm adding the module property using the log context, which is coming from Serolog, and it allows me to push a property to the log context, give this property a name and a value, and then this property will be present in all of the structured logs that get created inside of the log context, which is the lifetime of our Mediator request. And inside of the using statement, I'm logging an information log that I'm starting to process a particular request. I'm executing the request by invoking the request handler delegate. And then if it's a success result, I'm logging that we successfully completed the request. Otherwise, I'm adding an error log, and I'm also using the fact that I have a generic constraint here on the tResponse type, and all of my commands and queries return a result object, which means that I can access this result, and I know that tResponse is a result object, so it's going to contain an error value. I'm going to push this value into the log context as a JSON object by specifying the destructure objects flag as true, and this is going to allow me to filter my structured logs based on the error contents. Regardless of if this is a failure result or not, this is just a logging pipeline, so we're going to return our response from the handle method. We also need to configure this inside of our application configuration class, and remember that this is going to apply for all of our modules, so this is how we can easily add a logging pipeline behavior for all of our modules, commands, and queries. What I need to say here is add open behavior and then type of request logging pipeline behavior. And this is going to register this pipeline behavior for all of the Mediator requests that match the generic constraints. And now we are ready to test out our structured logging implementation. The application is running in the background, and you can see in the Docker desktop that the free containers that we configured in Docker Compose are running. So here is our API, our database, and the Seek container. The Seek dashboard is available on localhost 8081, and if I refresh the logs, you can see that we are already getting some values from the application startup. I'm going to send a few requests from Postman to fetch all of the categories that I have defined, and then I'm going to send another request to fetch a particular category, and then I'm going to send a request for a category that does not exist. And you will see that I get back a 404 not found response. If I go back to my Seek dashboard and refresh the structured logs, we can see that we get many values here. Now what I can do is filter these values by the module, and let's say I'm looking for the events module. This is going to filter out my structured logs and give me the concrete values for the couple of queries that I just sent. So here is the first query. You can see the log that we started processing the get categories query, and then another log when we completed processing this request. All of our structured logs include a request ID, which is the trace identifier of the current request, and we can use this to filter out all of the logs for a particular request. For example, if I take this trace identifier and update my filter to say request ID equals the trace identifier value, I can get all of the structured logs for one API request. And now I can get more contextual information. For example, here is a log that the request is starting, and this one is coming from the Microsoft namespace. Then we have another log that we are executing a particular endpoint. And if you open up this log, you can see that the source context is coming from the request logging middleware from Serilog. There's a similar log coming from the Microsoft namespace, and all of these logs can be valuable in identifying any potential problems in your application. And this brings us to the end of this lesson about structured logging. We implemented logging as a cross-cutting concern using the Serilog library, and we added a generic logging middleware and a mediator pipeline behavior that we're going to apply to all of the commands and queries inside of our application. We also added Seek to ingest our application logs so that we can monitor what is going on inside of our system. In the next lesson, we will be solving exception handling as a cross-cutting concern.